Hello students, how are you? Uh, Today in the new class of thermodynamics we'll discuss about the first day of thermodynamics. Okay, so let us start our class as usual with some chemistry jokes. So why did carbon marry hydrogen? Because they bonded well from the minute they meet. You know, carbon hydrogen, they have very much intimacy and then combine in a very good way to make hydrocarbons. So that's why, because they have very much intimacy. So carbon hydrogen bond is very strong. So anyone know any joke about sodium? No. So that is sodium. So what happens? What weapon can you make from elements potassium, nickel, and iron? So the name of the metal is knife. Potassium, nickel, and iron. That is our knife. Okay. What element is girls' future's best friend? So that is carbon, because they are fond of diamonds. So carbon is their future's best friend. Why are the chemists great for solving problems? Because they have all the solutions. Chemists have all the solutions. I asked the guy sitting next to me if he had any sodium hypobromite. He said, "Nah, bro." He said, "Nah, bro." So that is sodium hypobromite. What did the scientist say when he found two isotopes of helium? Think. Hey, hey. The scientists say, hey, hey. The scientists say, hey, hey. Okay. So लेट अस स्टार्ट. फिर वही केमिस्ट्री लाया हूँ, मैं तुम्हें पढ़ाने आया हूँ. केमिस्ट्री को कुछ और सुलझाने आया हूँ. So let us start with the topic. First law of thermodynamics. First law of thermodynamics, although it has been said in various forms, but this is merely the law of conservation of energy. So according to first law, energy can neither be created and nor destroyed. Okay, so energy can neither be created nor destroyed, or in other way we can say, or the total energy of the universe is constant. Total energy of the universe is constant. It can merely change from one form to another. It may undergo the transformation from one form to another. So this is thermodynamics first law. Now mathematically we can derive an equation. Suppose initially suppose at initial stage the energy of the system, the internal energy, suppose at the initial stage the internal energy is u1, okay, and if the system absorbs heat q, then energy is u1 plus q, and if a work W is done on the system, then U2 energy U2 is equal to U1 plus Q plus W. Now bringing this Q1 from this side, it becomes U2 minus U1 is equal to Q plus W, or finally it becomes delta U is equal to Q plus W. Now this is the first law of thermodynamics. This is the mathematical statement of the first law of thermodynamics, where this delta U is equal to, delta is the change in the internal energy, that is U2 minus U1. The change in the internal energy delta U is equal to Q plus W. So this is the mathematical derivation of first law of thermodynamics. Now in another way, how can we say this? इंटरनल एनर्जी चेंज को हीट संग वर्क डन से देते हैं जता, इंटरनल एनर्जी चेंज को हीट संग वर्क डन से देते हैं जता, इसे ही जमाना थर्मोडायनामिक्स का फर्स्ट लॉ है कहता, इसे ही जमाना थर्मोडायनामिक्स का फर्स्ट लॉ है कहता. सो I can say that internal energy change is explained by using Q plus W. So this is the first law of thermodynamics. This is the first law of thermodynamics. This is the first law of thermodynamics. Okay, so this is the mathematical statement for the first law of thermodynamics. Now let's see some situations where work done and internal energy change, how they are calculated. So during a free expansion, now what is free expansion? So what is the free expansion? Expansion of a gas expansion of a gas against zero pressure or in vacuum is called free expansion. Now in case of this free expansion, how the work done is affected? Okay, here the work done is 0. How? Let us see. As we know that work done is equal to minus P external delta V. If P external is equal to 0, then W is equal to 0 into delta V, or W is equal to 0. So in that way I can say that the work done during this free expansion of the gas is 0, or I can say no work is done during the free expansion of an ideal gas in vacuum. So here I can say the change in the internal energy, that will be equal to Q. It means some heat is supplied to the system, then and only then internal energy will be changed. Otherwise, because delta U is equal to Q plus W as per the first law of thermodynamics, if W is 0, it is the free expansion of gas in vacuum, then delta U is equal to Q only. So this is the situation number 1. Now situation number 2. Okay, if the process is carried out, if the process is carried out at constant volume, that is delta V is equal to 0, it means V final minus V initial, there will be no change in the volume, volume में कोई change नहीं होगा, तो delta V is equal to 0. So then the first law of thermodynamics becomes what? Delta U is equal to Q only. Because why it is so? Because in this case W is equal to minus P external delta V is equal to 0. Why it is so? Because here the term delta V is equal to 0, putting this value 0 here, so P external into delta V is equal to 0, so W is 0, so Q is equal delta U is equal to Q. Now is this Q is explained by putting a subscript V here below the Q. So here this QV is equal to heat supplied at constant volume. So when process is carried out at constant volume, then internal energy change is equal to Q subscript V. So I can again write it, delta delta u is equal to q v. Okay. Now at number 3, isothermal and free expansion of an ideal gas. So isothermal and free expansion of an ideal gas. So during this isothermal and free expansion of ideal gas, so here isothermal, so T is constant because the process is carrying out the process is being carried out at constant temperature, that name isothermal process, क्योंकि एक isothermal process है इसलिए इस दौरान during this process T है वो आपका constant है. The second thing is that W is equal to 0. Now why W is equal to 0? Because as we see free expansion against or free expansion in vacuum against zero external pressure, free expansion in vacuum. So that's why this W is also 0. Okay. Now here Q is also 0 because it was determined because Joule determined it experimentally. If you see the experiment of the Joule, then you will come to know that in such situation the internal energy change or say the heat change is also 0. So overall I can say here from this I can say that delta U is equal to Q plus W is equal to 0 plus 0. So delta U is equal to 0. So this is the during an isothermal and free expansion of an ideal gas. In that case the internal energy change will also be 0. Now putting this value of U, delta U, we can relate Q with work done for reversible as well as irreversible process. So putting this value there, so if delta U is equal to 0, अगर इंटरनल एनर्जी चेंज 0 है तो then putting this value in delta U is equal to Q plus W, so I can say Q plus W is equal to 0 and Q is equal to माइनस W. और आप इसको अगर माइनस W को थोड़ा सा ठीक है और माइनस W और Q is equal to माइनस P external delta V और Q is equal to P एक्सटर्नल डेल्टा V। कब? जब आपका वर्क डन कौन सा हो जी? फॉर इरिवर्सिबल work done. Okay, so then Q is equal to P external delta V, because delta U is here 0. Now same case, if delta U is equal to 0, then Q is equal to minus W, and Q is equal to minus 2.303 nRT log V final upon V initial. Cancelling this minus to minus, we will have Q is equal to 2.303 nRT log V final upon V initial. So this is the final equation. This is for reversible work done. So in that way you can relate, you can find out Q for reversible work done when delta is equal to 0, and similarly Q is equal to P external delta V for irreversible work done when delta is equal to 0. Let's see some more situation. So number 4, for adiabatic change, so for an adiabatic change, here Q is equal to 0. Why? Because in an adiabatic process, no heat is exchanged as the walls are adiabatic. In other words, we can say insulated walls. So if this is the situation, then Q is equal to 0, and putting this value in the equation, I can say delta U is equal to Q plus W, or delta U as per the first law of thermodynamics is equal to 0 plus W. So finally I can say delta U is equal to W, but this time we will have subscript delta U, subscript AD below the W. अब इसका क्या मतलब है? WAD is adiabatic work done, मतलब adiabatic work done, ऐसा work done in such a situation when the wall of the systems they are insulated, there is no heat exchange between system and the surrounding. उस सिचुएशन में यहाँ पे जो वर्क डन है वो डब्ल्यू एडियाटिव वर्क डन, और फिर देन टोटल इंटरनल चेंज विल बी इक्वल टू डब्ल्यू ए डी। तो ये कुछ हमने देखा कि जो इंटरनल एनर्जी चेंज के बारे में, फर्स्ट लॉ ऑफ थर्मोडायनामिक्स के बारे में देखा, फिर इंटरनल एनर्जी चेंज इन अलग अलग सिचुएशन में किस तरह से उसको हम फाइंड आउट कर सकते हैं, उसको हम कैसे हम डिनोट कर सकते हैं। आई होप कि आपको ये समझ में आया होगा, और फिर मिलते हैं किसी और वीडियो में नेक्स्ट टाइम। सी यू सून।